So in this video we are going to learn about the cells in series. Already started in the last class about the cells in series, and we learned the combination of cells, and in that case the cells were all identical cells and they are all connected in series. Now in this video we learn the different cells or the different types of cells which are connected in series. So in this case we will consider two cells only, so different cells connected in series. Now we'll draw the diagram. There are two different cells. I current is passing. This is one point, Z point. This one is the Y point, and this is the X point. X, Y, Z point also you can say. So EMF for this cell is E1. This one is R1, and this is E2, and this one is R2. So this is the setup. Now these two are cells. Actually you can put it in a box. Sorry, this is not Y, this is the Y. By mistake I wrote here, this is not the Y, this is the Y here. Now what is the potential difference between X and Y? You have to find out the potential difference between X and Y. So you can write Vxy is equal to Vx minus Vy. That is the potential difference. So Vxy is equal to E1 minus I R1. Okay. So also you can write from here. So Vx minus Vy is equal to E1 minus I R1. And the potential difference between Y and Z. So potential difference between Y and Z. You write potential difference between X and Y. Potential difference between Y and Z. So again we write Vyz is equal to Vy minus Vz. Also you can write E2 minus IR2. Now what is the potential difference between X and Z? So you can write Vxz is equal to Vxy plus Vyz. So which is nothing but E1 minus IR1 plus E1 minus plus E2 minus IR2. We'll take common here. We'll get E1 plus E2 and then minus I R1 minus R2. So this is the equivalent. So Vxz will be equal to E equivalent minus I R equivalent. Okay, so sorry, I have done mistake here. There will be plus here, sorry. Okay. here is plus. Okay, not this correct. So this is the formula. Vxz is equal to E equivalent minus I R equivalent. So now what will be the circuit of this equivalent circuit? So it will be here X and I current is here. Then with R equivalent, then you can write E equivalent, and it will become Z I current. So this is the equivalent cell. That means instead of these two cells, we can connect this cell. So this is the equivalent circuit of this one. So what we learned here, so in case of if n numbers of cells are there, if n number of cells are there, then E will be how much? E equivalent will be E1 plus E2 plus E3 En. Okay, and R equivalent will be R1 plus R2 plus R3 Rn. So these are the two formula when the different types of cells are connected in series. Now another thing is that, like if two cells are combined in series in such that the negative terminals of the cell is connected to the positive terminal of the cells. Okay, that means I want to say this E1 and E2 is there. If E1 is if the negative terminals are connected, I'll draw the diagram so that it will be easy for you to understand this. So let two cells combined in series such that let two cells combined or connected in series such that the negative terminal of a cell is connected to the negative terminal of the other cell. The negative terminal of a cell is connected to the negative terminal of the other cell. So we draw the diagram to look like this. U1 R1 like this. E2 R2, Y, X and Z. This is the cell. See, negative terminal of this is connected to the negative terminal of the other cell. So what will write here? Same formula, same thing. V X Z will be equal to U1 minus I R1 plus, here will be minus E2 minus I R2. Which one we wrote plus, it will be minus here. So now we'll do combinations here. So E1 minus E2. Okay. And one more thing, it's given here that E1 is greater than E2. So U1 is greater than E2. So consider this one, U1 is greater than E2. So U1 minus E2 plus, or you can say here, we have to take minus here, minus I, then R1 plus R2. Okay. So in this case, the equivalent resistance will be U1 minus E2 and equivalent EMF will be E1 minus E2. So you can write equivalent EMF. E equivalent is equal to E1 minus E2, and R equivalent will be equal to R1 plus R2. So these are the two difference here. Okay, you can check it out one more time. In this case, see all are plus, so that is why we've taken that one as a plus here. You can take a bracket here. So it came E1 plus E2, and in this case I've taken the negative side, so we'll take a minus here. So that is the difference. Okay. So this is up to this, and next class we'll continue with the cells connected in parallel. Same thing for the same type of cells or identical cells, and also we have to find out the equivalent EMF of the different types of cells connected in parallels. Okay, so thank you very much.